So today we're going to talk about section 5, which is on scatter plots and lines of fit. And so first of all, we've got a definition there of bivariate data. Okay, and so bivariate data, the prefix bi means what?
Two.
Two. And then variate is also a word for variable. So if you think about that, bivariate means two variables. And so bivariate data is data with two variables. And if you look at that example, I've got an example of a scatter plot there. And it is a set of data graphed as ordered pairs. And you see scatter plots quite a bit. Like in the newspaper, they'll have graphs there, and there'll be a scatter plot. We are going to create scatter plots today, and then we're going to do something known as the line of fit. And a scatter plot is used to investigate a relationship between two quantities. And so if you look at our diagram there, it has the year on the x-axis, and it has the number, thousands of travelers on the y-axis. So what can you conclude about the trend of international travel? It's increased, and so what would you expect the trend to do in the year 2015, 2020? It keep continuing up, yeah. Because if you look at it, the trend right now looks like it's going up. And so what we would do is we would expect, and we could conclude, that in the coming years, it's going to keep going up. Because that's what the trend is. And that's actually kind of surprising because with everything that's been going on lately, if you notice, it kind of stayed put. But I mean, it still didn't go down any, even with the financial hardships that have been going on.
Oh, is that an actual graph?
Yeah, that's an actual graph. Data was taken from the Statistical Abstract of the United States. And so a little bit about scatter plots. We're going to talk about something known as positive correlation, negative correlation, and no correlation. So if you look at that first one, positive correlation, and then look at the second one, negative correlation, and then look at the third one, no correlation. I'm going to give you about a minute in your groups. I want you to tell me what are the characteristics of each of the three, and how could you tell? So there's your minute. Go.
Some go up, some go down, some
It
go
looks
side
like
to side, some go up and down.
Dalmatian. It's like my moon. It looks like a Dalmatian.
And it looks like an N.
Or a pack.
It does.
Or like a heart with like
It's
a,
kind of a heart.
it's like
Yeah, it does
It looks like a heart that's mounted to like the y-axis.
No, guys, it looks like an elephant with a trunk.
Okay, so
We're gonna
positive correlation, what can you tell me? That group right there.
Goes up.
It goes up. So the trend of the data goes up. So the example in the first page that we looked at, that would have been positive correlation. This group back here, what's a negative? It goes down. The data is going down. What about this group here for no?
You can.
Hello? No?
There's just not really a pattern at all.
There's not really a pattern. There's not really a trend. It doesn't go up or down. The data is all scattered. Okay, so positive correlation, data goes up. Negative correlation, data goes down. No correlation means it's just kind of a mess.
And M stands
So if you look here at this graph, it says determine whether the graph shows a positive, negative, or no correlation. If there is a positive or negative correlation, describe its meaning in this situation. In your groups, you've got a minute. Go.
Positive.
Positive, and there's more weight.
People are
Yeah,
getting
and
more money.
As you would get more hours, you pay, you get more pay.
The more hours,
More hours.
More hours, more money. More
Two,
hours.
pay 40 hours, 600.
You actually get more for working
I thought about it.
2 hours than you for the sales.
I always forget.
All right, so this group right here, what is it? Positive?
Positive.
Okay, it's positive correlation, and what does it mean?
That
you
the
get-
longer you work, the more money you get.
The more hours you work, the more money you're going to
Kind
make.
of.
And that should make sense because when you think about it, generally, the more hours you put in, you are generally going to make more money. So let's go ahead and look at this next one. We're going to talk now about a line of fit. A line of fit is a line that best approximates a set of data. And so basically what's going to happen is you're going to have a scatter plot, and you're going to find the line that best fits all that data. So kind of the middle line. And so we've got an step-by-step process in order to find the line of fit. The first step is to make a scatter plot, and we're going to go through this in an example. And we're going to make a scatter plot, and then we're going to determine whether any relationship exists in the data. So we're going to determine, is it positive, negative, or no correlation. 2, we're going to draw the line that best seems to pass close to most of the data points. So kind of the one that fits the data. Okay, that's where the line of fit comes in. Step 3, we're going to use 2 points on the line of fit to write an equation for the line, which is something we've already done. And then 4, we're going to use the line of fit to make predictions. So we're going to find out what happens 20 years from now, what happens 50 years from now. So that is going to be our task. So let's go ahead and look at this example. Now we're going to look at this example. It is on the page I gave you is number 3. So that sheet I gave you, we're going to work through this one together. And so this is number 3. It says the table shows the number of cases of foodborne botulism in the United States for the years 2001 through 2005. Does anybody know what botulism is?
It's a disease control thing.
That's
It's
like
like
cancer.
It's kind of like food poisoning. Okay, botulism is a sickness you can contract there. Okay, for 2001 through 2005, notice that that came from the Centers for Disease Control. And so what it says to do is draw a scatter plot and determine what relationship, if any, exists in the data. So you have your plot there below, and so we're going to draw a scatter plot here. And so what I'm going to do first of all is look in 2001. It says there's 39 cases. So if you want to follow along with me and do this, in 2001 there's about 39 cases, so you're going to have a dot about right up there. Now obviously mine's looking a little bigger than yours is. I'm just doing that so that you can see things a little bit better, but it should be very close to the 40 but not quite touching the 40. The next one, 2002, we have 28. So 2003 we have 20. 2004 there is 16. And then 2005 is 18. So in looking at that data, what relationship exists?
It's a negative.
It's a negative. And now what we need to do is draw the line of fit. So what you need to do is have some sort of straight edge, whether it be the side of your book, the side of your calculator, or something. And what you're going to do, or even if you have a ruler on it, that would work too. What we're going to do right now, when it says draw the line of fit, we're going to go ahead and we're going to draw the line that best fits this data. Now, this has a negative correlation. Oops, evidently I've got some extra ones here. This has a negative correlation, and so since it has a negative correlation, that means my graph needs to go down. And so what I'm going to go ahead and do is move my ruler down, and I'm going to try to best fit the data. Now, when I try to best fit the data, that means I'm going to try to get as close to some of the data points as I can. So here I'm kind of close, but I'm going to go down even just a little bit more. There we go. Now, one of the things I'm gonna try and give you a hint. That one's gonna work for me. I'm gonna give you a little hint. We're gonna need to find the slope of this line. And so a good rule of thumb is to go through 2 points. Okay, and so if you notice, I'm actually gonna be going through 2 points here. I'm gonna go ahead and draw my line in. Okay, and so it looks like my line is actually going to be, oops, let me try and get that in there, right there. So I'm going to go ahead and close out my ruler. Now if you notice, the reason why I drew that line in there is because it goes through the point, this one right here, and it also goes through the point, this one, goes through the point, this one. Okay, so it goes through a lot of points, and that's usually a good rule of thumb to do, is to try and pick something that goes through some points. Reason being, you're going to have to write the equation for this line. And so it says write the slope-intercept form of the equation of the line of fit. So what are the coordinates of this point right here?
0, 40.
Okay, 0, 40. What are the coordinates of this point right here? 2002, 30. What are the coordinates of this point right here? 2003, what?
2000.
3.
Isn't that 2003 and a half?
Oh, 2003, right, you're right. Let's go ahead and change that, 2003.5, and then 20. Okay, now the 2 points I'm gonna go ahead and use is I'm gonna use the last 2 points. The reason why I'm not gonna use the first point is because notice here, that distance isn't the same. I mean, when you think about it, that value, it says 0, really is actually gonna be about 2000.5. So I'm gonna use these 2 ones in green. What I need to do now is find the slope. So how do you find the slope between those 2 points? y2 minus y1. So I'm gonna go ahead and write them over here, I think, so that you can see things a little bit better. And 2003.5, 30. So very first thing what I need to do is find the slope. So the slope is going to be,
2003.5, 20.
oh, did I write, okay, 20, sorry, I didn't write that one right. It's gonna be 20 minus 30 over what?
2002.
2003.5 minus 2002. So let's go ahead and calculate that. What is 220 minus 30 gonna give me?
Negative 10.
Negative 10 over what?
1.5.
1.5. Okay. What's that gonna be in simplest form for a fraction?
Negative 2/3.
Ideas? What's that?
Negative 2 over 0.3.
Okay, so as a fraction with no decimals, what do you think the simplest form is gonna be? For those of you who are wondering, let's do this. Okay, so it'll be negative 100 over 15, which reduces down to
3 over 1.
negative 20
Oh.
over 3. Okay. Alrighty, so now if you notice it said right in slope intercept form. So first of all, I've got y equals negative 20 3 x plus b. Now what do I need to do if I want to put it in slope intercept form?
Plug in y.
Plug in y and x. So I'm going to use the point 2002, 30. I'm going to plug in 30 for y. Now, for those of you who are wondering, where on earth did she get the point 2002? I got that from this point right up here. Now, I could have used the 2003.520. I could have used that one, but I'm going to go ahead and use this one, just because it didn't have the decimals. And so now I need to calculate that. What is negative 20 thirds times 2002? It'd be kind of a big number over 3. 40,040.
13,300.
Yep. 40,040
46.
over 3.
Yeah.
Okay, now what we need to do is subtract that from both sides, which is the same as adding. So you're going to add 40,040 over 3 to both sides. So what is 30 plus 40,040 over 3? You got it?
30 plus 40, no, never mind. I know 30
That'd
plus
be
40,000.
400. I mean, 40,150.
40,130
30.
over 3.
Oh.
Now, is
God,
this
there was
divisible by
two in
3? Is 40,130 divisible by 3?
No.
No, the reason being, if you add the 4
Yeah.
plus the 1 plus the 3, that's not divisible by 3. So my equation, I'm going to now plug 40,130 in for that. So your equation should be y equals negative 20 over 3x plus 40,000, oops, forgot to put the x in, 40,130 divided by 3. Okay, now that is not the only answer you could have. Okay, believe it or not, when you draw a line of fit in, there are numerous answers you can have. And so somebody might have drawn a line in that maybe didn't go through those points, and they went through 2 other points, and that's fine. So that's the thing tomorrow, we're going to have various answers that we can go through. And so now what we're going to do is we're going to go through one of these in class. So I need you to open your book. And your assignment is on pages 250 through 251, number 4 through 10. But I need you to open your book because we're going to go through one of these in class together. So what you need to do is you need to finish this worksheet. The worksheet shouldn't take you very long because there's only 3 other problems. But we're going to go ahead and do, if you notice 4 through 7, it just has to determine whether they're the correlations. We're actually going to do number 8 in class. So number 8 says, refer to the scatter plot of gallons of milk consumption per person for selected years. Use the points 221.75 and 421 to write the slope-intercept form of an equation of the line of fit. Okay, so on number 8, they tell us that the points are, can somebody read those to me again?
221.75,
Yep.
421.
And 421. So what they're doing on number 8 is they're saying, we want you to use these points. We don't want there to be a bunch of different answers. And so in this case, there's only going to be one answer you can have. So the very first thing I need to do is what? Slope. Yep, find the slope. So I'm going to find the slope here. So to find the slope, what do I do?
y2 minus y.
Yep, so 21
Negative
minus 21.75 divided by
4 minus 2.
4 minus 2, good. Okay. So what does that come out to be? What is 21 minus 21.75?
0.75.
Negative 0.75
Over
divided
2.
by 2. What does that come out to be? Negative point what? 75 divided by 2 is?
0.66.
0.15.
I think it should be 0.375. Somebody else get that? Okay, so that's my slope. Now what I need to do is put that in slope-intercept form. Can somebody tell me, excuse me, what I need to do next?
Y
Y equals negative 0.375x plus b. What point do you want to plug in?
421.
I would plug the 421 point in. Okay? So if I plug in 21 for y, and if I plug in 4 for x, so what is negative 0.375 times 4? Negative 1.5? What do you do now?
The
Add 1.5.
Add 1.5 to both sides, very good. And so I get 22.5 equals b. So my equation now becomes y equals negative 0.375x plus 22.5. So this is part A. But we're not done with the problem because notice there's like a B and a C and a D. So in B, it says predict the milk consumption in 2020. Predict the milk consumption in 2020. So let's look at the graph. In the graph it says years since 2000. Okay? So I want to predict the milk consumption in 2020. So when I think about that, what x value would 2020 correspond to?
21. No, 20.
What x value would 2020 correspond to if I'm looking at years since 2000? 20. So what they want you to do is they want you to use the red equation here. And all you need to do is plug in 20 for x. Now when you do that, you're going to get a y value. So I get y equals negative 0.375 times 20 plus 22.5. Now I'm going to let you be able to finish that one. Okay, I've given you enough help on B. Let's look at C. Predict in what year milk consumption will be 10 gallons. So for C, when it says milk consumption is 10 gallons, what value is that? Y equals 10. So what you're going to have to do here is you're going to have to solve the equation. So you're going to have 10 equals negative 0.375x plus 22.5. So you're gonna have to solve that. So what would you have to do first to solve that? Subtract 22.5 and then D, it says it is reasonable to use the equation to estimate the consumption of milk for any year. Is it reasonable? So you need to think about that. Okay? And so you can go ahead and finish that. So I think I've given you a good start on 8 that should help you with 9 and 10. So once again, 4 through 10 in the book, and then you need to finish the practice sheet 4-5 that I gave you. If you work now, you should be able to get most of it done.
Can you go back to the page that had the equation for number 3 on the worksheet?